So hi everyone. Today we'll be discussing about what is association analysis and how to calculate association rules using the a priori algorithm with an example. So let's get started. So first of all, let's understand what is association analysis and why it is important. So assume that you are in a supermarket where you can see different items like biscuit, namkeen, jams, butter, etc. Now, eventually, if you have ever noticed carefully, there is a certain set of items that are kept together, like namkeens and biscuits. So you won't assume that your biscuits would be near toothpaste or like your mops near biscuits. So eventually there are certain combinations that the supermarket follows. So you can see ki, okay, there particular type of food that are kept together and rest and other things are kept at certain sections. So why it does so, like, and how they are doing this. So basically it is a form of recommendation only. So if you go to Amazon or Flipkart or some other e-commerce app, you can see that people providing you like in the app you get suggestions like people who bought this also bought this and all that stuff. So eventually this is all related to associations. So even physical stores like supermarkets can provide such sort of um, uh, arrangements so that eventually that can help them to increase their revenue. So it can be the case that a person who goes to buy a biscuit packet will see namkeen and will get instigated by that. Okay, let me buy a pack of namkeen as well. But eventually that won't be the case when he's going to buy a mop. So when he goes to buy a mop, his intentions are pretty different, and when he sees a biscuit, he's just not able to connect. But though, in case if you're keeping some sort of a floor cleaner near the mop, it can be the case that he might take it because the intentions are matching. So, what sort of a strategy that the such physical stores can do to make these associations rule? First is that either they arrange all the popular products on the major counters. So that is one, but not a very feasible one. So because this will lead that the other material in your store won't get bought enough, and eventually you will have a surplus amount. So so on one side a certain section of items would be selling at a rapid pace, but on the other side things are just stocking up. The other being we try to figure out patterns in sales and place items that are bought together close to each other. Hence, like if a person is coming to buy bread, there are high chances that he might buy milk or butter as well. So we find out such patterns in the in the sales data, and eventually we can figure out such combinations. Association rules basically helps us in determining this association between different items in grocery or in e-com, etc. So this is what association analysis means. Association analysis means figuring out such pairs which are related together, which are brought together depending upon the data set. Now that data set can be about transactions, the data set can be about anything. So let's get us started. Like as we have got a basic idea of what is association analysis and why it is required. So let's get started with the basic concepts first. So assume that we have a list of items that are present with us. That is bread, diaper, milk, beer, eggs, cola. Considering them as I. So item set is what is an item set? These are a few terms that we will be discussing first before jumping on to the algorithm. What is an item set? An item set is a subset of I. I, that is the total number of items present. So, for example, if we have total number of items as bread, diaper, milk, beer, eggs, cola, an item set can be bread, diaper, beer, milk, milk, cola, etc. Any subset of the set I. Also, any subset with k elements would be called as a k item set. So if it so in case of example bread diaper, we have two items, so it will be called as a two item set, etc. Disjoint item sets, so item sets which don't have any element in common are called as disjoint diaper set. Like pretty much clear with the definition itself. Bread diaper, egg beer can be taken as an example because there is no common item present. Transaction are the item sets in the training data set. So basically assume that we are running a supermarket, and all the transaction done by the customers is the data that we have got. So any transaction that, like any combination of items that are bought together, will be taken as a transaction. So as you can see here, that assume that this to be a small transaction list that we have got. So the first transaction includes bread, milk. The second includes bread, diapers, beer, eggs, milk, diapers, beer, eggs. So all these items present in the data is are called as items, are called as transactions. What is an association rule? Assume that I1 and I2 be two disjoint item sets. So we have discussed earlier what are disjoint item sets which don't have any element in common. So if I2 and I1 are associated, then I1 leads to I2. Let me tell you what does this mean. So if I1 equals to beer and I2 equals to diapers and egg, and if they're associated, this would mean that beer would lead to diapers and egg. So if a transaction has beer, it might have diapers and eggs. There are high chances that it might have diapers and eggs as well. This is what association rules tells us. So if we have I1 giving I2, this means that if a transaction has I1 subset, there are high chances that it has I2 subset as well, but not vice versa. So it is not necessary that if the transaction has diapers and egg, it would have beer also. So it is not a vice versa. It's not it's directional in nature. Now you must have understood how these association rules can help us. So, if beer is bought, diapers and eggs are also bought. This is if we have this association rule, we can place these items together. This sort of rules can help us to build out sections like customer who viewed this also, like in Amazon. So I have added an example here. You must have seen this. Customers who viewed this item also viewed these items. It does make sense. Now, how to figure out whether items at I1 and I2 are associated? Now, that's a big question, and this is what we would use Apriori algorithm for. But let's understand a few concepts before jumping on. Support. For a rule I1 giving I2, when support equals to I1 union I2 upon total n. So, for example, if we wish to know that whether bread gives out bread as I1 and milk as I2, whether bread and milk are associated to each other. So we will be calculating their joint frequency, bread union milk, and total number of transaction. So the frequency of bread and milk coming together is 3. Bread milk, bread milk, and the total number of transaction is 5. Hence the support for this rule, bread giving milk equals to 0.6. Confidence, for a rule I1 giving I2, confidence equals to frequency of I1 union I2 upon frequency of I1. In case of, again, the example bread and milk, we would be first calculating the frequency of bread and milk coming together upon frequency of just bread coming in the transaction, that is I1 equals to 0.75, because bread comes 4 times. Hence the support for the rule bread giving milk equals to support equals 0.6 and confidence equals to 0.75. Now, association rule discovery means that, so we have calculated support and confidence. We will understand how we can use support and confidence to form a association rule. Support for any rule R should be greater than the support threshold, and confidence for any rule should be greater than the confidence threshold. So we would be setting up two major thresholds. One is support threshold and another is confidence threshold. And eventually, if for a transaction, a pair of subsets, that is I1 and I2, if both the support threshold and confidence threshold is crossed, we'll assume that to be an association rule. Now, considering a real world scenario where we have thousands of items in a in a supermarket. Now, going by mathematics, if we need to check out all the possible combination of rules to figure out association rules, we would be checking around 3 raised to power d minus 2 raised to power d into 2 plus 1 rules, where d is the total number of items. If d equals to 1000, which is pretty usual for any supermarket, this number can go as high as 5.15 into 10 raised to power 47. Now, if you can think this number, this is very very big number, and what we're talking about is to calculate support and confidence for each of the possible combination, and the total number of possible combination is this. So hence, this is very computationally heavy and not viable also. So what we wish to do is to figure out a quicker way to determine these rules rather than following a brute force approach. One of the ideas that has been come up is that we first of all calculate the support for each of the rule, and support where the support is greater than support threshold. Now we only calculate the confidence for only those rules which have a support greater than the support threshold. Hence, instead of doing both support and confidence together, what we are doing is that we are first calculating support and then calculating confidence. So if you remember the formula for support, it was frequency I1 union I2 upon total n. Hence, remains always common. So it's just calculating frequency of union I1 union I2. Now, in case of confidence, what we are calculating is frequency I1 union I2 upon frequency of I2. So there are two terms to be calculated. Hence, what we are doing is that we would be calculating confidence only for the rules which have a support greater than the support threshold. But still, this is going to be a big calculation. So what we are planning to do is that to bring in a priori algorithm, the a priori principle. So let's understand what is a priori principle. An item set is called as frequent if it has a support greater than the support threshold. Now, there are two major points within this principle. If an item set is frequent, a support is greater than support threshold, all its subset are also frequent. Now, let's see in this particular example. Assume that CDE is frequent. That means any subset of CDE, CD, CEDE, CDE is also above threshold, and hence what we would be doing is that if we figure out a support threshold, if we figure out a rule uh, which has a support greater than support threshold, we won't be calculating the support for the remaining subsets. So for example, if support for bread, beer, eggs is greater than support threshold, we won't be calculating support for bread, beer, eggs, bread, eggs, all the combinations of the three elements included, because following the a priori principle, the support for all these combinations would also be greater than support threshold. Similarly, if an item set A is infrequent, then all its superset are also infrequent. So it's just the opposite of the first rule. So if we figure out a subset like, for example, AB is not frequent, its support is less than the support threshold, then all the superset that we form, any element getting included in this particular set, ABC, ABD, ABE, that has AB as a subset, would also be infrequent and can be rejected instantly. So as you can see, using these two basic ideas, what we would be doing is we won't need to calculate the support for all the possible rules, but just for a few rules, and depending upon and using the a priori principle, we would be skipping rest of them. So now let's jump onto the a priori algorithm. Let's understand how it helps us to calculate frequent item sets, for which you can calculate confidence and eventually know accepted association rules. So do keep this in your head that a priori algorithm is used to calculate just the frequent item sets and not the final association rules. So the first step is to calculate is to figure out frequent one item set. So if you remember, I told you that one item set means that one element in the item set. This can be done using setting a threshold for the first one, because one item set means that we would be calculating frequency for each element in the item set, and we'll be taking up only those elements which are frequent, and now frequency can be determined by the threshold, setting up a threshold. Now for iteration, now next we would be going for a for loop that goes from 2 to k, where k is the total number of unique items. So if we have I equals to 5, if we have 5 unique items, so the algorithm goes from I equals to 2 to 5. So it would go to I equals to 2, I equals to 3, I equals to 4, I equals to 5. Now eventually this includes two steps. One is candidate set generation. So generate candidate set using making a cross join between fi minus 1, cross join fi minus 1. So I basically represents the kth item set, ith item set that you're looking for. So if we wish to figure out most frequent two item sets, so in that case I becomes a 2, 2 minus 1, 2 minus 1. So frequent one item sets we would be cross joining. Similarly, if I equals to 3, then what we would be doing is we would be doing frequent uh, two item sets cross frequent two item sets. This can be a bit confusing. We will be discussing in the below example. Once we would form the combination, then we need to go for candidate set pruning. So we would be calculating the frequency for this new generated candidate set using the previous frequent item sets. So, and if the threshold if the support for this particular rule is greater than the support threshold, we keep that set, else we reject that set from the particular frequent threshold frequent set. So what is happening, again we would need an example for this. I will be telling you an example, but for now let's understand what is happening. First of all, we are calculating frequent one item set. That means using some set of threshold. Now we go for a loop, that is I equals to 2 to k, where k is the unique number of items present in the list that we have, total number of items, take it as n or k, whatever we call it. So starting from 2, what we would be doing is that we would be generating candidate set from the previous frequency. So if I equals to 2, we would be considering frequent one item set. If I equals to 3, we would be considering frequent two item set. If I equals to 4, we would be considering frequent three item set. and we would be cross joining them together to form a new combination. So for example, now once we form a new combination, we would be going for a candidate set pruning. This means that all the combinations that we have formed in the previous step, candidate set generation, we would be calculating support for that, and eventually we would be checking out with the support threshold whether the support threshold that we set up is less than for this particular rule or not. If it is greater, then we consider as a frequent ith item set. So there is an exception for I equals to 2. So when I equals to 2, every element from one item frequent one item set would be considered. But when I equals to 3, we would be merging only those frequent two item sets which have the first element common. We would be arranging these elements in the item set in alphabetical order. So do remember this also. And similarly, when when we have I equals to 4, we would be merging only those frequent three item sets whose first element is common. So let's understand this. Assume that we have these frequent two item sets: beer diaper, beer eggs, and eggs cola. Now we wish to generate candidate three item sets. So what we would be doing is that we would be cross joining these pairs, forming out these beer diapers cross join beer eggs cross join eggs cola, beer diapers cross join eggs cola. Now if you see, in case of beer diapers and beer eggs, we have the first element common, that is beer, so we get a new candidate set, beer diaper eggs. It's a candidate set still, we haven't calculated the support yet. But in case of X cola, the first element is not matching with any of the group. Hence, for the rule beer diaper cross join X cola or beer X cross join X cola, we would be rejecting these rules and we would be considering just beer diaper eggs as a candidate three item set, because for the rest of the combination, the first element is not matching. So let's understand everything with an example. Assume that we have been given these five transactions in information. We have set up support threshold to 0 0.6 and confidence threshold to 0 0.6. Now, as total number transaction is 5, and we are using Apriori algorithm just for generating frequent item sets. So any item set which has a frequency of 3 would be considered as a frequent item set, because 3 upon 5 equals to 0 0.6. Hence, the support for that particular rule would be greater than or equal to the support threshold. So first of all, let's calculate the frequent one item sets. Subsets is just one element. So for this, we need to calculate the frequency of each element and that we have in the list. Uh, so we get a frequency for beer equals to 3, bread equals to 4, so on and so forth. So you can see that the grade values that are cola and eggs have a frequency of 2 and 1 respectively, and they have been rejected because of that. As I told you that support like the frequency has to be at least 3, because the total amount transaction is 5. So to have the support to cross the support threshold, you need to have frequency of 3. So here we are rejecting cola and eggs in the frequent one item set, so they won't be considered in the next item set that we are creating. Now creating the candidate two item set. So candidate means that we are first of all creating the combination, then we will be checking out the support. So candidate one item set, what we are doing, we are just cross joining with every possible combination. So here you can see that beer bread and beer milk have a count of 2, while rest of them have a count of 3. So in that case, what we are doing is we are rejecting these two because the threshold is less, and we are accepting the remaining 4 in the most frequent in the frequent two item sets. Now to generate item 3 3 item set, we will be going for frequent two item set cross frequent two item set, leading to formation of bread diapers milk only. Now as candidate 4 item set is not possible because we don't have much elements in the candidate 3 item sets only. So for this, what we would be doing is that using these three elements, we would be creating all the possible combinations that we can have. And this is our frequent item set using Apriori algorithm. So once we get our frequent item set, that is bread, diapers, milk, the next step is to generate rules out of this particular frequent item set. So you must have seen that we haven't had any I1 and I2 coming in. It was just a set of items that for which we are calculating the frequent item set. So now using the elements in the frequent item set, we would be forming all the possible combinations. That is bread, diaper, diaper, bread, bread, milk, milk, bread, milk, diapers, diaper, milk, bread, diapers, milk, milk, giving bread, diapers, etc. And for each of these rules, we will be calculating the confidence now. So if you remember, the formula for confidence was frequency I1 union I2 upon frequency of I1. So here I1 becomes the element which item set which is on the left hand side of the arrowhead. Now for any of the rules for which the confidence is also great, is also greater than the confidence threshold would be considered as an association rule. Now you must have understood that by using the a priori algorithm, we first of all calculated the frequent item set, and eventually using that frequent item set, we created all the possible combinations, and then we calculated the confidence to get to final association rules.